Hello Internet, welcome back to our mesh depression videos. So I don't know when you're going to be seeing this. I'm going to be gone this week, or I was gone the previous week. So I'm recording all of these in a batch, and I'm hoping that I'll be able to get them edited and uploaded periodically throughout the week. I don't know if that's going to work because I don't know if I'll actually have internet or not. But that's currently the plan. If it doesn't happen, there's going to be a lot of videos happening the second week of January. And if it does work, then you won't notice a difference. At least that's the plan right now. So we're going to go through these and hopefully everything's going to go smoothly. If not, then sorry. So we're working with our mesh deformation shader. Is not a shader. We're actually dynamically changing the positions on our mesh. So if I go here, each of these spheres, as it hits our terrain, it depresses that position. And so if I pause this, you can see that we're actually carving lines down the middle of our mesh. And then as I step through this and move forward, we continue to depress the mesh more and more as things collide with it. The problem with this is if I unpause this, it's super slow. Like this is running, it was running extremely slowly. Like normally it runs at 200 frames a second. It drops down to like 3 when we're having all of these refreshing our mesh constantly. And the reason it's so slow is because the way we're doing it is we are having every single collision regenerate the mesh. The problem with that is there is 1, 2, 3, 4, 5, 6, 7, 8 balls hitting it. So every single frame, we're regenerating our mesh 8 times, and you're only seeing it once. So there's no point to those other 7 times, and we're just wasting a bunch of time. We're sending 7 additional meshes over to our GPU that it doesn't care about because it's never going to draw them. So what we want to do is we want to fix that. We want to take that out, eliminate all that extra work, and make this work better. So what we have is a generated quad here, which has all of our standard stuff. It's our generated plane from the first video in the series, and then our deformable mesh from the second video. And then what it does is it takes our original vertices, and then as things hit them, it depresses them by our maximum depression based on our modified vertices. So in order to fix this, what we need to do, what's happening is when something collides, it adds a depression to our object. So we have a physics deformer that is going to add a depression when it hits something. The problem with this, or when something hits it rather, it's going to add a depression. The problem with this is that, well, we add a depression, but then then things go horribly wrong, because what's happening here is we update our modified vertices and then we set the new vertices to the modified vertices. We don't want to do this here. We actually don't want this here at all. Instead, what we want is we want a update, and we want to set them there. And so we can take everything out of that spot. So we're not, every time we collide with something, we don't want it to update that. But what we want to do is we want to collect everything that should be deformed and then batch update it. And so what this will do is everything will modify the vertices, but it won't do anything with it until it hits this update, which will run once per frame. So instead of basing this off of the number of collisions per frame, we're basing it off of the number of frames, which cuts down on the complexity. So if I run this now, it should be significantly faster. We're still hitting 3. And I'm wondering why that is. I think it's because of the size of our grid, but we can fix that as well. So we have this set vertices. I'm going to, let's see, what else is going on? This is going to be super slow because there's 64 squared vertices, 65 squared vertices actually in our plane, which is a lot. That's not a trivial number. And we're doing that for we're iterating over all of those for every single collision. So I think the best solution to this is probably not to do this. Like, this solution works great if we just have like 2 spheres. So if I disable all of the other ones and just put 2 there, this actually runs fairly smoothly. We're running at 200 FPS. And then if I enable the other ones, we drop down, but even that, so 6 collisions, runs right around 45 FPS, which we're not doing anything else in this scene. So that's not great performance by any means, but at least it runs. The issue is that it still sucks. So what I think the next step is to actually take out all of this deformation that we're doing and actually put in something a little bit cooler. So what I'm thinking we can do is we can use tessellation, and then we can use a displacement map. And so the idea we're going to have here is we're going to have a 2D texture that is going to map the height of our terrain. And then what we want to do is we just want to edit that texture as things hit it. So instead of checking every vertices and then modifying them manually, if we just modify the vertex there, not the vertex, sorry, if we modify the texture a little bit, put like a little dot there, then we can actually just use tessellation and then use that to actually move the vertices themselves in our shader. And so that way everything should be significantly faster. It should work faster. And the cool thing is that since it's just a texture, we're actually going to be able to get significantly higher vertex density, and we're going to be able to achieve significantly higher deformation, just shapes, I guess. So I'm going to go and pull in Unity's sample tessellation shader, and then we'll go from there and see what we get. All right, so I have a really basic tessellation shader brought in, and just to show you what it's doing, we're using Unity's Phong tessellation. There's an example from Unity's documentation, and I literally just copy and pasted that in, and then I set it to a material called the Displacement Map Tessellation material. And if we bring this over here, you'll see what it's doing. So all of these black lines are the material, or are the new vertices. So what you can do is you can actually adjust this based on the edge length. I probably don't want to increase that too much because it'll get a little bit slow. But we have this edge length that we can adjust. And so this adjusts how much or what is tessellated. And so you can see all of this is happening on the GPU, and it actually changes based on distance. So as I get further away, we get less tessellation, which means we're spending less resources on rendering something further away. But as we get closer, we get significantly more detail. And what we can do then is if we actually bring in our displacement texture, we'll actually be able to take that and actually modify things so that it works. So that's the idea. And just to give you an idea of where we're coming from, I just literally brought in a quad. So we're going from 4 vertices to a ton of vertices. And so this is the power of tessellation. This is why it's so cool. The disadvantage is I believe you need OpenGL 4 or DirectX 11, which now shouldn't be an issue, but it was 3-4 years ago. So anyway, this is what we're going to start with. To show you the code, here's what we needed to bring in. If you're familiar with surface shaders, this should look fairly similar. This is pretty much the same. Actually, everything here is the same, and everything up here is the same, except some of the properties. But then the only differences are we have a tessellation function, tessellation function, it looks like. I think this is an argument that we're passing in. I'm not entirely sure. I would have to check. But I believe that is just saying use this value for how we're tessellating. And then we're not light mapping it. So I believe that's because with tessellation, if you light map it, it doesn't necessarily work out right. I'm also not entirely familiar with that. So we're kind of delving into some new things that I haven't done. But we'll see where it ends up. So what we have is we have a vertex, a normal, and a texture coordinate. Those are going to get passed into our tessellation function. And then Unity already has built-in functions that are going to handle tessellation. So we don't need to write that for ourselves. This right here is what is doing all of the hard work to actually generate all of those vertices and place them on the screen. So the way it does that is it actually looks at the length of like the edges between vertices and says, what's the distance of this? And if it's greater than some threshold, it cuts it down. So what we need to worry about is actually modifying the vertices generated by this. And then what else do we need to do? I think that's probably it, actually. I may need to bring in a vertex shader, which I believe we already have. So to cover this a little bit in a little bit more depth, when you see something like this in this pragma sentence here, this is kind of declaring what your shader is going to do. So we have a surface shader, and the surface shader function is surf, which matches this down here, and these arguments have to match. Then it's a Lambert shader, which is sort of the standard shader. Then there's a vertex function, which is going to actually be where we actually calculate our vertices. There's a tessellation function, which has the tess edge name. And then there's this tess fong, which seems to map to this. You can add other things up here, like there's, I think, alpha, if you want a transparent shader. And then there's like full forward shadows or something, which adds a few other shadow functions and things like that. Well, I'm not gonna dig into all the features. If you care about that, Unity's documentation on this is fairly decent. It takes a little bit of looking to find it. I'll try to find a link and drop it in the description, or I'll forget and you'll have to dig yourself. A little Google should find you what you need. So what we need to do is we need a displace none. Let's actually call this our displacement. So our vertex shader is going to be our displacement, and we actually don't really need to do anything in the surface shader part. We could do some stuff, but for now this is fine. All it does is just draws a texture, and you can give it a little bit of a tint. If we wanted to add like normal maps and things like that, we can do that, but I'm not going to worry about it. So now that we have that, let's plug in our new displacement map. So we have a displacement map, and I'm just going to note that we're going to be using the R value from this texture. And so it's going to be a 2D texture, and we're going to start it off with a default white texture. So if no texture is given, it's going to use white. And so what we're going to do is we're going to look at the red channel from this texture. If it is 1, then we're not going to move. Well, let's say if it's 0, we won't do anything. That makes way more sense, because then we can just use multiplication. If we had 1, it'd be a little bit more work. So if you get black or 0, there's no displacement. If you get 1, then there's going to be some sort of displacement happening. Then let's also plug in a displacement amount. Oops. And so these are just parameters in Unity. When you look at a shader or a material, you get these displayed to you and you can edit them. They're also available in your scripts, so you can modify them that way. So all you're doing here is declaring it, giving it a name, giving it a friendlier name, so something that will actually display in the editor, and then giving it a type and a default value. So that's what this is doing. The other thing you have to do once you've done all of that is you actually have to go down into your code and you actually have to give it a name. So we have a sampler 2D, and this is going to be our displacement map. And that should be good. And then we also have a float of our displacement amount. And so now we can get both of those values into our shader. And then the only other thing we're going to have to do is actually modify this displacement value. And then everything should just work, I think. But I do not know. I don't know what goes in here. So we may have to do some digging there. I'm going to leave it for now because we don't really need it. But what I am going to do is go back to our physics deformer. And we're going to copy this. And we're no longer going to modify the actual shape of our mesh. Instead, where was it? Generate quad here. So if I go down to our scripts, let's create a new one. Physics displacement map deformer. And so what this is going to do is it's going to do the exact same thing. The only difference is we are going to have a what's it called? We're going to have a texture in here instead of anything else. And so the hard part with this is we're actually going to need to be able to calculate. We need to be able to calculate what the texture is, where we are on the texture. That's the hardest part here. Once we have that working though, this should work. So I'm going to start off by, actually I think you can probably get that from the contact, can't you? Contact dot, no, I don't think you can. Glider. Yeah, okay. So since we can't get that, let's think of another way to do that. We'll probably come up with something clever. I hope. If not, then this is going to be really boring. But what we need is a texture 2D. Do we want to make it public? Sure. Deformed texture. And then we're going to have a material that we're going to bind to. And so this is going to be our deformed material. And that's going to need to be set to whatever material you want to deform. And then we're going to set this texture onto this. And then the only other thing I want is an integer with the size width. Sure. And we'll give this a range between 100 and, let's say 64 and 2048, which is massive. If you ever need a texture that big, then you're doing something weird with this. But we're gonna pretty much give you a choice between any of these numbers. This way, Unity's editor isn't going to allow you to go negative, which would break everything. So that's what we're going to focus on. And then all we need to do then is create the new texture. So create a new texture 2D with our, let's actually call this our size. So we'll create our new texture with the size like so. And then so with textures by default, they are not modifiable. You cannot change them. If you want to be able to change them, you have to do something. And I don't know what that is. What? Texture format? No, this isn't right. I do want it to be ARGB 32, I think. No setter though. So we can just get that. That's less helpful. So let me demonstrate what I'm thinking about, and then I can figure out why I can't find it. So if we select this grass, for example, if we look at its settings, there's a bunch of fun stuff in here. You've got like the texture shape. I don't know why you'd need that. But you can say like, is the alpha channel transparency or something else? And then there's a bunch of other stuff. You've got the wrap mode. So if you want to clamp the texture or have it wrap around. There's the filter mode, which you can do point, bilinear, or trilinear. So bilinear is going to be dots. So it's not going to interpolate between things. So if I make this huge, sure, we'll save that for now. If I make this massive, you'll kind of get an idea of what I'm talking about. You can see that instead of being nice and smooth, now that it's a point filtering, it's not interpolating between any of this. So you get these hard colors, you get sort of that pixelated look. If you do bilinear, it's going to attempt to filter it. And then if you do trilinear, that's going to add in, I believe, it's going to use the distance formula. So the distance from the camera to actually use mipmaps. I'd have to look it up. It's been a while since I've looked into that. I'm not totally familiar, but the idea is with bilinear, it smooths things out. And then when you add trilinear, there's a third component that gets added in. I think it might be the mipmaps, but I could be wrong. I don't know what. This is anisotropic filtering. Don't know what that's for. So we're going to ignore it. But the important thing, the reason I'm talking about this is we want this read write enabled. This has to be true. If this is false, things are going to break. But I think since we're generating our texture, I don't think we need to worry about this. But I'm going to have to make that guess because I'm not entirely sure. So I can get rid of that. We don't really need it. And then actually I can take this quad and actually just throw it on here. Will that work? And so we can actually, let's just use this quad as our mesh here. And then we can get rid of this mesh renderer here. So we don't need to generate. We don't really need any of this. So the reason we don't need any of this is because we're not doing anything dynamically anymore. It's well, we're doing things dynamically, but we're not modifying our mesh. All of this is going to happen on the GPU now. So we don't need all of that stuff. We can just use a static mesh like this. This works. So now that we have that, I can jump back here, grab our script, our map deformable thingamajiggy, and then that's wrong. Sorry, we want it attached here, so it will detect our collisions. This one doesn't matter so much. And then we can take off that, and then this should compile. We should be able to point it at the material we care about. And then the only important thing we're going to need to worry about is that our material has to have that shader, or it isn't going to work. But hopefully that isn't a problem. So if I jump back here, grab our material and throw it on there, we should be able to give it a size, let's say 64. And that should just give us a 64 by 64 texture. I don't know entirely what it's going to do, but let's do that. Take our deformed texture, generate it, and then take our deformed material. And we're going to set the texture of it to our, where was it? What did we call it? We called it the displacement map. So all you have to do is pass in the name in your shader. If you're using one of Unity's standard shaders, those are going to be listed and you're going to have to look those up. We already have that, and so we just have to give it the name of the property we want to set, and then the deformed texture. And so now this material's displacement map is now that texture. So if I go here and run this now, I should see we get a fully white deformed texture, and then we have a displacement map tessellation with that displacement map here. And that is a very boring gray thing, but it works, and that's what we're going for. So anyway, that is the basics of setting our material. Next, let's go through and actually plug some things in. So we have all of this happening. What we want now is we actually want to draw on this. The first thing is our texture needs to start off black. And so to do that, we want a for each, not a for each. This is probably not the best way to set colors in a texture. You can do it all in a batch. I'm not, but you can, and that's probably going to be significantly faster because it's just one update instead of, I don't know, the size squared updates. So we might look into that later, but for now, I think it'll be enough to at least get us started so we can start working on things. So I'm going to take the deformed texture, set the pixel at x, y equal to color.black, just so the entire thing becomes black. And then for debugging purposes, I'm actually going to set our main texture as well to the same material. And that way, even though we don't necessarily get the displacement working, what we will get working is we'll get some markings going. So we've got this going, it's argument out of range. Oh, that's this. Never mind, ignore that. Kind of confused why it's not black. Oh, never mind, I know what's going on. So we set all the pixels to black, and then what we have to do is we actually have to apply this. And so the reason you need to apply this is if you're modifying your texture a lot, you need to send back the texture to the GPU. So all of this is happening on our CPU. The GPU and the CPU, they can talk together, but they don't share information. So if the CPU knows something, it has to tell the GPU, this is this, or this has changed, or something like that. And if you don't do that, the GPU is not going to know. It's not going to be checking for those updates. So you have to go and actually manually do that. And if you don't, it's never going to know. So to do that with textures, you have to do this apply. So if we go through this now, we should see a black texture. And that's just because our texture is now black and our GPU has picked that up. So now that we have that, well, the two next things we need to do is, I'll probably actually chop these into two videos just because they're fairly separate things. But the two things we would need to do is we need to map some values. So as things hit this material, we need to take those and actually displace the texture at that position. And to do that, you actually need to calculate where things are. We aren't doing that right now, which means we don't actually have a way of saying, oh, you hit here, so that is this point on our UV map. So I'll probably have to split those off into separate things. The other one is actually doing the tessellation and displacement, and that's separate. We need the actual map to be generated first, but actually modifying the vertices is kind of an interesting concept. It's similar to what we were doing, just we're doing it in a shader on the GPU instead of doing it on the CPU in a C# script. So I'm going to leave this specific video here, and we'll pick those up in the next videos. So if there's anything you guys want to see, let me know in the comments. If there's anything you guys didn't like or want me to improve, let me know about those as well. But till next time, see you, Internet.